Alright, quick little review on your three logarithm properties that you use quite often. Product means multiplication, quotient means division, power obviously is an exponent, okay? The first thing I said in class today was that logarithms are really what? Exponents, okay? Alright, logarithms are really exponents. So, let me recall back to Algebra 1. When I'm multiplying with exponents, x to the 4th times x to the 11th. When I'm multiplying, what do I do to those exponents? I add them together, right? Okay? If you remember that when you're working with exponents and you're multiplying, when you're doing a product of two things, what do you do to the exponents? You add them. That should help you recall the product property. Okay? Basically, if I have a logarithm of a product, okay, if I have some logarithm to whatever base of a product of two things, I can actually do each one of those items in that product separately and add them together. I can add each one of those together. So in other words, I can do log to the base b of m plus log to the base b of n. Okay? Sometimes it's helpful to expand one logarithm into two. More times than not, though, you're going to go from two logarithms back down to one. Okay, that's the product property. Why does it work? Well, logarithms are exponents, so they follow all those exponent rules. Anytime you're multiplying with exponents, you add the exponents together. So I won't go through as much detail with this one. When you're dividing with exponents, what do you do with those exponents? Subtract them. When you're dividing with exponents, you can actually just subtract each one individually. How about powers? When you take one power and raise it to another power, if you have x to the 5th and then you raise that to the 4th, x to the 5th raised to the 4th, what's the answer? X to the 5th raised to the 4th. X to the 20th. What did you do with those exponents? You multiply them. When you take a power and you raise it to another power, you multiply those powers together. Okay? So if I have a logarithm, okay, if I have a logarithm, and that's raised to a power, okay, sometimes you'll see parentheses on there, sometimes you will not, okay, does not matter actually in this case, okay. You can actually take that power and bring it all the way out to the front, and then just multiply the two things together. So that is your power property. So product, quotient, power. These are three properties that you will definitely use when you're solving exponential and logarithmic equations. You recall those somewhat from Algebra 2. A little bit. Okay, that's fine. You don't use logarithms a ton, okay, other than when you're working with exponential functions, so I'm not shocked that you might not recall them, okay. Why are these properties, why do they hold true, or what can we relate them to kind of help us remember? What are logarithms? Exponents. Exponents, so they follow all of your exponent rules, right? When you multiply with exponents, you add. When you divide with exponents, You subtract, and when you raise exponents to more exponents, you can multiply those exponents together. Okay? That's a test question, just FYI. Okay? Why? Alright? So, you will definitely use those. I'm going to show you on this last one here. Okay? I asked you this a little bit earlier today, right? Okay? I asked you to find the answer to this on your calculators. It was 1.6 something, right? So in other words, I wanted to know what this was equal to. I'm going to use a couple of things that I just showed you to show you why on your calculator taking log of 10 divided by log of 4 actually works. Okay? The first thing I'm going to have you do is change forms. Okay? So this is in logarithmic form. Change it to exponential form for me. What would it be? 4 to the x power equals 10. Okay? Now, we're going to logarithm both sides of the equal sign. So first step I did what? Put an exponential form. Next step I log both sides, which is okay. I mean, as long as you do the same thing to both sides of the equal sign, it's all good, right? Okay. Now I'm going to use that power rule. Where can I move my x? Use the power rule. Where can I move this x? Out to the front, right? So x times the log of 4 equals the log of 10. And now if I said solve this equation for x, or get x by itself, what would you have to do to both sides? Divide by log of 4. So x ends up equaling log of 10 divided by log of 4, which is what I told you. Some of you might have to do on your calculator in order to do this, right? Because some of you were not able to type that subscript 4 in there. So here's why taking the log of the big number divided by the log of the base would work. I should basically prove to you algebraically how that works. Yes, no, questions? What's going through your head right now?